Go.
Hi, my name is Claire Arthurs, and we're going to find the basis of the col A and the column space of A and the null space of A, where A is this vector. So the general method for solving that kind of problem is to first find the echelon form of the vector, and then wherever the pivot positions are, those vectors are the basis. And then for the null A, you're going to find that you're going to augment it with zeros and do complete row reduced echelon, and wherever the free variables are, you're going to solve for this spanning set, and that's going to be your null space of A, the basis of the null space. Okay, so I just went straight to augmenting just because for simplicity and less steps. So when we do that, I noticed first off that -1 and 1, if you add these two rows together, that becomes a 0. So I did that first, and so that's what I got there. And then for the next step, I multiplied the first row by -2 and added, as you can see there. And then for the next part, I multiplied by -9 and added. So I got that. So the next part I want to get rid of is this 4 right here. So I'm going to multiply this by -2 and add it here. So we got that nice and pretty. And then right after that, we want to get rid of the -12 here, so multiply by 3 and add, and so we get zeros at the bottom. And then also we want to get rid of these 2's, so we're going to divide by 2 and get 1 and -1. And then here I want this to be a 1 as well, so divide by -4 to that row, and so I get right there. And so right here we can already tell where our pivot positions are, and so then we can tell where our pivot columns are. So that can give us the first part of our answer. So the basis for col of A, we have to look back at the original. So the answer, you put it in this format right here: 1, -1, 2, 9, -1, 3, -2, -5, and finally 1, -1, -2, and -3. So that's the basis for col of A. And so for the next part, we want to completely row reduce, so we're going to get zeros above the pivot positions. So in order to do that, first we're going to add the second row to the first to get rid of that -1, so down to zeros. And then we're going to go over here, and we're going to multiply by -1 and add it to up here. So that becomes that, and because this is a free variable, we can't reduce any further to here. And from here we can find what our null space of A is. So we translate this back into the formula representation, or to the equation representation. And so we already know that this form came from AX equals 0, where this is x1, x2, x3, and x4. And so x1 equals 5/4 x4, x2 equals x4, x3 equals 7/4 of x4, and x4 equals itself. So the spanning set for this is x times the vector 5/4, 1, 7/4, and 1. So the basis for null of A is 5/4, 1, 7/4, and 1. And that's how you do it. Thank you.